Okay, thanks. Hi, my name is Thomas. Thank you for inviting me to your conference. I liked it so far a lot. I work in Berlin, Germany for Amazon Web Services. And I'm here today to talk to you about what we have done in our company right now, in our team, and why we have done it, and kind of why we wanted to use a technology called web components, and sadly, why this did not work for us and what we did instead. So let me talk a short second about Amazon Web Services to give you some context why we started that project. So as said, I work for them, and Amazon Web Services is probably known best. Amazon itself as a company is known for the retail organization, for buying stuff online. But there's also a big part of our company that's like Amazon Web Services, and we offer kind of cloud computing. So we are a cloud computing provider. That means we sell or rent out IT capacity for your needs when you need it. Doing that, we have to create also user interfaces for our products. And I'm not sure if you have used our products before, but if you log into our main interface, you will see something like that. And what you can see here is just a big list of links to different services. So we have over 50 services that you can see here that we offer to our customers. It's different products that help you run your IT project, whatever it is. And if you see that long list, and if you followed a little bit what we have done in the last years, you will also maybe know that just in 2015, we launched 722 new services or main kind of important features. Right? So kind of a lot of output, a lot of innovation going on. And the thing is, for every feature or service, we need an interface. And how does a company work like that? How can we create so much output, like so many offerings to our customers? It works in a maybe unexpected way. We actually have very, very, very small teams. And each of these teams is responsible for a service inside the company. That can be a service that is offered to our customers, or it can be a service that is offered to another team inside. The Americans call that 2 pizza box sized teams. So the idea is if you have 2 large American pizzas, you can't feed your team during a lunch break, your team is too big, you have to split up. So obviously there's good eaters, and there's bad eaters, but the idea is if you have around 8 people, you should split up. And so you have small teams, and you have a very strong ownership. That means your team is responsible for the whole, right? So we don't have a QA team, we don't have a team that deploys our stuff, so we don't throw shit over the wall and say, good that we're done with that. So we our CTO says, you build it, you run it. So that means all the operations, that means all the deployment, right? If you just write your code and you never experience the pain in production, that's dangerous, right? So there's a strong ownership model with the small teams. And there's also another idea that these teams are independent, right? That gives them the speed you have seen before. They can just have an idea and run with it and test it and just build it. Right? And the other requirement, obviously, is they need some sort of API because others need to make use of it. So they have a very defined, kind of in and out, basically. And because teams are independent, they also have a lot of choice around their technology stack and methods. And there's one kind of interesting learning in our company that there's no golden hammer or there's no silver bullet. There's not one thing that is the best in certain category. There's a lot of things, and they all have their purpose. And that also includes processes, languages, and tools. If one team in our organization really, really wants to do waterfall, I don't know one, but if they really would want to, then let them have it, right? If they will learn their lesson or they will make it actually work. We don't care. We don't influence the teams. Most teams actually go with Scrum and Kanban of approaches. Then we have a couple of teams that actually follow a process they call continuous burrito. So it really doesn't matter. Like kind of same as like kind of for programming languages. Like if people think their problem fits best in Go, like kind of use Go for God's sake. Like no one will stop you. There's just one rule: we are not allowed to use PHP for security reasons, but all the other tools are available. Like it's really the only rule we have around this. And that's true for all the other tools. Like kind of you have CI tools, you have all kinds of tools. Kind of pick what serves your problem best, right? So there's no single answer. And many factors play into that decision, right? There might be that like technology X is technically the smartest and most clever thing to solve your problem, but your team has a lot of existing code or prior knowledge in a different product. Then it's probably the smarter choice to stick with that for now to get shit done, right? So there's many things that kind of happen in our company, and the core idea is small teams and they pick their stuff. And in a company like ours, it will be impossible to do something else, right? If we would have a team that is like, okay, we are the smartest in the room and we decide and I randomly pick Angular, then we might be right or not, but like kind of, I will have fights with other teams and it's just not worth it because it's not about the technology choice, it's about getting stuff done. And especially in the world of JavaScript, developers love their JavaScript frameworks. And this is just a random list of when I had interactions with different kind of frameworks around the time. So it's not when they were created, but like kind of when I was excited about them or when I kind of felt there's a lot of going on, a hype around these different projects. And the reality is nearly all of them are still alive. YUI is actually discontinued, but like kind of XJS just had a new release. Kind of the last 4 weeks, they kind of had a new major version. So like all that stuff is still out there. That probably means that in our company, someone is still using it, right? Because the product is existing for quite a long time already. Or they have a team that just like kind of are huge fans of that product, or it actually serves their use case best. Kind of, as I said, luckily not all of them are used, but like kind of a lot of them are used. So the question is like kind of, how can we help these small teams to be fast, right? Because if they own a lot of the technology stack and the choices, that's a lot, right? It's a big burden on them. So we have other teams that can help them be faster and more efficient. So the question is, how can we help them best? And we started with what was very common in Amazon. We started a new team. We made a pitch for a new team early last year. And the team name is Chocolate Factory. And I will come to that later, so there will be chocolate. And the team's only focus and team goal was to increase developer happiness and productivity. That's all I can. This is the thing we do in our small team. And we picked our first project. And the first project is really just around how do you make the creation of interfaces easier and more productive and better. So we are going into brainstorming mode on what to do. The first option we had is, oh wait, let's talk to the design team and create a design guide. And this has a low initial cost, right? So you just look what you have, you follow the atomic pattern process. You see, oh, this is like kind of an atom, this is more like a molecule. You can just, okay, this, and you derive what you actually have and try to standardize and write up what the specifications are. Though on the other side, there's a very high cost to enforce compliance, just because you have a set of laws. Not everybody is following them. You can write up as many laws as you want. If you don't have a police to go after everyone and say, no, you're not compliant to the law, I put you in prison, and teams will go, no, you will not. And also, I have to ship my stuff, I don't care. So you have, this does not work for our organization, really. And I think it does not work for any organization, because you need to have something that's actually compelling and not something where somebody goes with a whip and says, like, you have to do it, you have to do it. It's not working. It's also very hard, because if you just create a design guide, you create a lot of screenshots and people start using Photoshop and all the bad things. And then you have something that's kind of static and hard to maintain. And what happens is that you have the different pages of the design guide, and then there will be one smart-ass developer who says, you know what, like in this screenshot, that looks different than over here, right? And I'm not using that shape. Table flip, go away, right? So it's just not working. And also, kind of, there's a high cost in like kind of the long-term part of it. So you have to implement the design guide for every JavaScript framework you're using, or every front-end project you have, basically. And only the guys that use Angular 1.4 can share the code. But as soon as you jump to a different version, something might not work, and like kind of you get in all kind of levels of hell. And also, any change to a style guide is impossible, basically, because you have to run after all the different projects and do all of this stuff. So yeah, CSS frames works much better. You can render example pages, so like kind of something like Bootstrap, for example. But I think they're fundamentally broken because they start with the CSS and make everybody create the markup that matches the CSS. So in terms of kind of thinking about that building, let's imagine the exterior design guy and the interior design guy met. It's like, oh, let's like make a striped carpet, right? It's all nice, but you have to start with the foundation, with the architecture, with the markup, and then apply. You need to kind of define the function and how stuff works before you go and kind of define colors. Because else you will go into, oh wait, right, if we architect like that and the markup is like this, it's kind of contradicting and it applies a style you did not intend to. I think it's backwards. It needs to be the other way around, basically. And then there's no clear boundary. People overwrite stuff all the time, so you can't make changes because there's no good split in ownership, right? You can't just provide a CSS framework and expect everyone to not do anything with it. That can be a problem. Also, if we invest in that, we wanted to do more. We want to have it incorporate best practices around accessibility and like kind of additional functionality. And so we ended up with option 3, something in code somehow that supports all the frameworks and they currently actually use browsers and it decouples the styles and the markup, should be performant and accessibility and all the good stuff. And like obviously has tests and has deployment plans, right? Like kind of if you have all the independent teams building and innovating, you need to have a model where you can just update your button basically and say, okay, I will not break everyone somehow. So it needs to have a strong idea on how you roll out a change. And like kind of obviously, because we're a small team, we kind of rely on a company internal open source idea. So all our code internally is available. I can go over and look at any other code and steal from it, right, and be inspired. But we want to foster that inside the company so that others kind of help create more of the user interface patterns for us. And kind of reading up on the internet and all of that, we're like, oh, web components, that's the thing. A short like kind of reminder. So web components is a combination of different upcoming web standards that are currently developed. And these web standards are custom elements which allow you to define new type of DOM elements on your website. HTML imports, which is basically a way to, instead of just saying import CSS or JavaScript, you can import HTML. It's not that important for our case. Templates, yeah, kind of the template idea out of like kind of handlebars or whatever other templating engines. They have directly a version for that is native to browsers. And the most interesting part, like Shadow DOM, which basically gives you the encapsulation of your DOM tree and the styles. So the idea is it kind of becomes unbreakable and scoped. That's a really nice idea. So yay. The problem though is the support. And like kind of, I'm like kind of not bashing Internet Explorer here or Microsoft, not at all, because I think they made an awesome move with Edge to finally release a browser that is auto-updating. I'm actually more looking at Safari right now, which concerns me more. So like kind of, the problem is, this is the official like kind of compliance against the standards described on webcomponents.org, the website informing about all of that. And we actually found out, you know what, that is not even half true. It's actually way worse. And then there's obviously polyfill for everything, so we tried to use the polyfills. But like kind of in the beginning of our project, we kind of gave up after a month or two to do the research, how do you do that. Kind of some of the polyfills are really heavy, and they all have the problem in the end that they're asynchronous by nature, right, because they have to load, which is a problem for a lot of the other kind of JavaScript frameworks we want to use in conjunction, as we can't kind of educate all teams how to ensure that everything is created already. So we will create a big mess of support questions and how to use our framework with their framework with our web components and so on. So we stepped away from that and we said, that's just, it's too much of a moving target. The standard is changing. For example, for Shadow DOM, kind of the browser vendors haven't decided whether the so-called CSS piercing is available or not. So if you can say your small web component has a defined API on whether you can change certain attributes inside or not, which gives like a hell lot of different set of problems they have to solve first. So we're like, you know what, like that's not something we can use in production in the next couple of months. And if you want to kind of have a little bit more experience on kind of how web components will feel eventually, you should have a look at Google's project Polymer, which is basically an abstraction layer on web components that pulls in all the polyfills and gives you a rough idea on how that might work eventually. So we said, the components thing is the right thing, but we can't use the technology. And we kept the ideas. So we learned a lot during our initial research, and kind of we still wanted to have the custom elements part of it, and that we can attach special behavior to the individual elements in the interface. And that also allows us to have a very kind of defined upgrade path. We don't mess with existing DOM elements. We don't get in the way, right? We have our own part in the DOM that has is basically kind of has its own namespace and is kind of separated from the rest. And we wanted to have the style encapsulation for the idea of gradually onboarding, right? If you have a large project, an interface, you want to have the teams kind of not basically throw everything away and start from scratch. You want the team to kind of adopt, right? If they're touching a website, a part of their project, and they can replace all the alerts on that page because we have created an alert component, right? Then they might do it. If I tell the team, you know what, you have to redo all your stuff, they're like, that's not going to happen. But if they can, like, kind of, I do kind of change a little bit of functionality and let me clean up, let me refactor, and then they kind of onboard slowly and they change and add stuff from our library, basically. And in the end, they need to have a very well-defined API so we can interact with the different elements. And we also need that to allow all the different JavaScript frameworks to work with our components. So in general, like kind of quickly, the architecture of what we have built is, so the browsers are different in level of like kind of what they support and do not support. So we created a very thin layer runtime that makes that even playing field for the functions we need to kind of proceed with our project. And then we offer a framework-specific wrapper to kind of guide through the different, or kind of enable the different frameworks. And then we obviously have to build the components themselves. So simple in the end. So what is the runtime? So the runtime allows our custom elements to be declared and defines the lifecycle. So I can now put an alert in the page and I can clean it up afterwards. So really like kind of the basic interactions. It also defines custom events. So kind of that I have a close event on my alert, for example. Property and region handling. So all of our components have certain properties. So I can say, oh, the alert is an error alert or an informational alert, that kind of stuff. So properties and regions. That means like kind of in our user interface, we have certain placeholders where we can render content. And the rendering of the content actually happens with a render engine called Mithril. It's one of the virtual DOM implementations. We picked that one. If you want to know why, you can talk to me later. We offer also the validation of the property type. So if somebody, instead of entering a number as a property, enters a string, like kind of our framework said, not working. And also we have basic metrics, which I will come to later. The property type checking is working because we do our development with TypeScript. So we picked our tools as well, and we're like, you know what, like kind of looking at our case, TypeScript is actually a good solution. And like kind of all our stuff together, like kind of looking at the architecture again, for 20 components we have built already, plus the runtime, it's 20 kilobytes zipped. and it's another 19 kilobytes for the CSS. You probably can optimize on CSS later, but it's not right now. And we have implemented wrappers for the different frameworks, Grid, Angular, React, Angular 2, and actually web components. So we basically solved the IT, kind of the development problem, as every good developer does, by adding another layer of abstraction, and then we can translate to everything. So even like kind of when web components becomes real, we can remove our stuff and basically have a direct diversion, and the rest becomes like kind of goes into some kind of maintenance mode for everyone that is still using Angular 2 in 2018, because that will be heavily outdated, but whatever, right? It's still working. But everybody that's using something new can just use the new. What does such a wrapper do? So it's not magic, it's not thousands of lines of code, it's more like in the hundreds, like so between 150 and 300 lines of code. So it's really simple in the end. So the Angular wrapper is a script that declares an Angular directive for each component at runtime. Pretty basic. The wrapper for React is a wrapper around the React create class function, and that converts our component specification into the native React components. So React has already an idea of components, we just converted to that exact specification. And for Grid, Grid has a library that is a widget API, and we just create classes for that are generated at build time. So the others are JavaScript, and it's Java based. So we do that at build time, the other at runtime. And this then allows the developers that work with Java and Grid to also benefit from our work. So a lot of build up and talk, right? Let's get to the code part. So this is a tiny component we built for the conference, or Dennis built for the conference. Find me there it is. So all the component does is, if I click on it, it changes the year and the color, right? So if that is of use to you, you could now just use it in your project and it has the two attributes, right? The title and the start date, that's all it does. So it's maybe not the most brilliant thing to build, but to explain you what we do here. And what you see below is the not updated, but the initial state of the DOM structure you would have in your browser. So you have the custom tag, and then inside you have what the render function provides or is creating inside that component, which is like something that is very simple. The cool thing with that idea now is, if we ever decide to make that component smarter or change the API, right? We don't rely on people not messing with our inner workings, right? Like it's a contract that we don't allow people to mess with our inners. They just have to use our API. If they would use our inner working, they're prone to break, right? If you want to, you could use the video player element in the DOM and also try to manipulate the inners to make the styling of your play button different and all of that. But all that is tricky. It doesn't really work across browsers. So we have a similar idea of saying, you know what? All you care about is that component. Like, you as a developer don't care about the inner workings. You don't care about the styling. It's all our concerns, all our business. And now the JavaScript on how that actually, it's all the JavaScript that is needed, or TypeScript is needed to write this component you have seen, which is in the end really simple. You just say, oh, I have two properties in my component, and a set type checking is in place. So if you would provide, instead of a string, a number, an integer, and the other way around and so on, it would actually fail. You can specify default values if you want to. And then the interesting part here is the render function, which basically is, so the M is for mithril, which creates the inner DOM structure, and in this case also includes the logic of the component. So that's all we need. Next to the properties and the render function, we also would have a place to create events and methods for a component, so you can create more complex things as well. So how do you would use that? I talked about the different frameworks and how to interact with our components through the frameworks. If you're using vanilla JavaScript, all you would have to do is specify two things, our runtime, our project in general, and the individual components or set of components you want to use. So you put that in your header. And then, like using plain JavaScript, all you do is you create a component and kind of set the attributes if you want to, or properties if you want to, and then attach it to the DOM and you're done, right? So it's really simple. It's actually what we have done in the slide before, so it's a JavaScript-based like kind of slideshow thingy, so that's exactly what we have used. And if you're a React developer, you find the slide prior to totally ugly and unusable and so wrong, right? Because you want to use a React way. And because of the wrapper that you just have to include in addition, you can do the JSX style tags inside like kind of your React app and do whatever you want to do there. Which then just, all you have to do is conference title code fast and you have the same result, but the React way. Same with Angular. So what we support here in addition is framework-specific functionality. So for Angular, for example, we also support ng-model if you kind of, because you want to use that as an Angular front-end developer. And kind of different style, same result, right? So it's really agnostic to the framework. And even for grid, right? So that is how a grid looks. It's the same thing. It's Java, and I have no idea how it works, but if people do that, and it works. So, right, the important thing, kind of, this idea of the abstraction and like kind of how we define UI interface components, it works, all of it, across all the different frameworks. So even for Angular 2, which is still in flux, it seems to work. It's pretty cool. So we saw a lot of benefits doing that, what we have done. Like onboarding for new teams is very faster. So if you have a team that wants to say, oh, I have to create a new product or a sub-part of a product, how do I get the styles from the design folks kind of implemented? I've never worked on such a big project, or we have junior developers just onboarding. They can pick it up very fast. It's below a day. It's hours, if not 1 hour, to get started and get the results. The integration and documentation guide is about 2 pages. That's all. It kind of really this and super extensive. Like it's idiot-proof. I tested myself. I can do it. Like it's really. I'm not a programmer. That's why idiot-proof. So developers, it's kind of what we learned as well. Developers want to be compliant, but we have to find a way to make it easy for them, so that they're not kind of stuck in like kind of a problem space. They usually don't work because they want to solve the business problem. They don't want to touch the CSS. That's really complicated for them. For me, it's the other way around, but it's how it is, right? We also currently test like kind of how we roll out design changes. That looks also very promising. So how to support different themes at the same time. And the important thing is we sparked also engagement in our company around the project, so that our project scales faster and more people create more components. Because in the end, what we have is opinionated guide on how to create this, and we created all the framework how to create that, and others just kind of, instead of creating the one UI component for Angular, they just create a generic one, and every team can use it. So that worked well as well. Other lessons learned, kind of the decision, which was a really hard technical decisions to not use the polyfills, actually paid off. So in general, like kind of reinventing the wheel is a bad thing. In our case, it turned out to be a good thing, and we are happy. And we still can change it, which is interesting. So we can remove it again, this layer. And a strong SLA is key to build trust. So kind of with the publishing of our components, which is just an offer to other teams, we also published a service level agreement that describes if we break you, how do you escalate? You can call us any time in the day. This is where you create the tickets. This is how fast we promise to answer to tickets. This kind of contract you have with the customers that builds trust and makes them actually use your products. And kind of people liked our forms most. People seem to struggle a lot with form elements kind of in the web, which is a sad thing because the web is a lot about form elements. But even simple things like a tooltip can be complicated because like, people have very different opinions about tooltips, how they work. So kind of might be a lesson learned. And then obviously automation, all kind of all the stuff we do, our documentation page, our test permutations, all of that, no one writes a single line of code. We created something that takes our component definition and automatically creates the whole documentation page, creates all the tests for that against all the different browsers and all of this, because this is tedious work that adds no benefit to what you are doing, what your business problem is, right? You should automate everything where there's no real value. And kind of like the message for you is try to do the same. Try to put all your knowledge around front-end into code as much as possible, even if you don't have to support all kinds of frameworks at the same time, which might be a problem that's unique to large companies. Do it for your framework. Try to not just have a design guide. Try to have something in code as much as possible. And share this in the form of code, because code can be, as you know, can be versioned. You can have comments in that. You can kind of say why you have done something, why you have decided so, why did you change the decision later. All of this is documented automatically, and you can roll back and this kind of stuff. Kind of last thing about usage of our components. As promised, damn it. You should see a super fancy graph I worked on in the night that goes this and like this, like hockey stick, right? I said I should not touch code. So we started in April last year with the project, with the team. We had our first customers in production in July. By now, 18 of the teams and Amazon users building the interfaces. And yeah, I said you would have seen like, oh, awesome success, but okay, you don't. So that means what is the future for our team? We basically proved inside the company that it's a working idea and working project, so we will grow the project. We will hire more people in Berlin and Seattle for that. And we will build more tools that help our developers. Like we're thinking, and designers will help think about how to automate like kind of design tools like Sketch and so on better. And we also want to open source what we have so far. So similar to the keynote this morning, right, kind of we built something and tried it ourselves, and we are confident enough in that case of that project that's actually worth sharing, and we will share that. That's it for my talk. Thank you for your attention, and I'm happy to answer questions.
Hi, hello.
And for everyone that asks questions, okay, you ask anyway, but there's chocolate.
No, thank you.
It's good chocolate.
Thank you for good talk. I'm really wondered that somebody have approximately the same problem as we at Yandex. Mm-hmm. And I would like to ask a couple of questions. First of them, could you please describe a little bit more about volume of your component library? How many components do you have, and what kind of them?
We have 20 right now, and they're like kind of as simple as an alert, right? So like kind of a warning. We have different form elements. We have something like a card, like kind of very simple small stuff. We started with the very small things, and went away like kind of basically bottom up, right, to more complex stuff. We haven't touched something like a chart, right? There's good chart libraries out there. It's a problem for later, right? We wanted to validate the approach, and we had a lot of positive feedback already. So we had, for example, we started the project by asking teams how much time they think they need to spend to be visually compliant, compliant against accessibility rules we have to be compliant with, and so on. And the estimates are horrifying, like kind of how many work weeks and months there are. And we said, okay, that's enough to hire a couple of people to try to solve it for everyone. And we started bottom up, and we're getting bigger and bigger. We are currently in a state where we have elements that have nested elements that combine functionality. For example, in a form, usually you have something where you have a label and some sort of input, error message, a hint, like this kind of stuff. And we have an abstraction component that has a specified API for the kind of combination of the sub-elements we have already created. So we're working up our way.
So the deepest level of nesting of components is about 2 or 3?
No, it's unlimited.
I mean, right now.
Right now it's 2, 3. Yeah.
And what about hard JavaScript functionality, like I don't know, dynamically opened boxes, like custom selectorialization. Do you have something like that?
Yeah, we have a very complex select thing because the design team wanted to have something that is not the standard select for scalability reasons. So our select right, kind of is smart about how many options you have inside. So it could render as a regular select, or it can render as a select with a search function if there's plenty of content in there. This kind of stuff you can do if you have a component, so not every team has to invent this kind of functionality.
Yeah, okay. And the last question, so do not catch a microphone all the time. With that heavy JavaScript functionality, do you have problems with the integration with libraries and frameworks like React? I mean, as I can see at your code slide, there is your own custom events model and modification of DOM, and how it's going with the React and the libraries like that.
We basically have our we namespaced everything, so we don't get in the way.
I mean, there is a problem when you modify a DOM in React out of the React model.
Yeah, I know what you're going for. I wonder how to answer that. Maybe we meet later about that detail. But yeah, I know like the back channel basically. If you get into the way of the core functionality of the project, we're not doing that. Okay, maybe. Yeah. Maybe the microphone.
Мы имеем возможность встраивать наш код в React, и таким образом мы преобразуем наш компонент в React компонент. Поэтому React никак не конфликтует, потому что для него это обычный React компонент.
На русском или на английском? Мой вопрос был в том, что если мы в нашем JavaScript коде, который написан не в React терминах, модифицируем DOM, то React это не понравится. И то есть, если я правильно понял твой ответ, то типа все модификации делаются через React API, и React об этом знает. Но не очень верится, что там настолько можно прокси настроить.
А давайте сейчас сконцентрируемся на вопросах к Томасу, а потом в экспертной зоне поговорим по этому поводу.
Okay. Just find me later for more chocolate or stickers and questions maybe, if we run out of time at some point.
Thanks for the report. If I understand correctly that you have made a wrapper for popular libraries, whatever your developers can use any of them, knowing only
I
your
don't
wrapper.
have speakers here.
Я предлагаю, спроси на русском, поможет Денис.
Я правильно понимаю, что это вы сделали обертку для всех популярных фреймворков, чтобы ваши разработчики, не зная эти фреймворки, зная только эту обертку, могли использовать?
About Cadbury? Okay.
So the question was, is it necessary was to develop wrappers for our developers that we don't teach our developers to know frameworks, only our wrappers? So that's not so. Это неправда, потому что каждая команда использует свое решение, наоборот, свой фреймворк, который они выбрали. И наша задача стандартизовать использование кода между фреймворками, поэтому наша библиотека, она адаптируется под каждый фреймворк.
И следующий вопрос. Вот.
Thank you, Thomas. My name is Alexei. I want to ask you, do you have anything like component versions?
Yeah, we have. So, yes, yeah, currently
about upgrades to the new versions. How?
Exactly. What we have in general is a very kind of mature deployment process in the team, because every team owns their stuff, right? They're responsible for the deployment, so they take care of it. So we have good CI and CD processes. We don't rely on that. We have our own very extensive test suite with our own fake products that use the stuff. So if we would introduce a breaking change, basically, we would be using SEMVer, so semantic versioning, where we indicate that you can upgrade to a new version if you want to, but that there's including a breaking change, and we would generate the appropriate automation. And if you really want to do have people move to a new version, what you should, besides not breaking them, what helps is have scripts that automatically run through their code to fix stuff. So if you have the possibility with your breaking change already kind of publish a script on how you can run through your code, if you want to update, so it's kind of becomes a task of 10 minutes, people actually do, because they want to have the new feature or like new styles or whatever it is. It's a management task, it's not so much an IT task. There's IT basics you have to do, don't break people, use Semver and all of that, and then there's a management task to convince people and help them.
Thank you.
Hello. My question is about management of development of these components. As you said in the beginning of the presentation, you have very small teams that focus on their own stuff.
Yep.
Who is responsible for developing new features for the component library?
Our team.
Oh, you have a
Dennis.
separate team, yes?
Yeah, like our team is the service team to actually do that task.